It's kind of wild when you stop and think about it. So much of our digital world, everything from your contacts list to the search results you get, is built on this one really simple idea. There's this hidden logic that's constantly working behind the scenes, turning total chaos into perfect clarity. And today, we're going to pull back the curtain on that fundamental process, sorting. Yeah, just look at this. On one side, you've got this mountain of raw, jumbled up data, kind of like these packages just thrown on a conveyor belt. And on the other side, perfectly organized, super useful information, like the contacts list on your phone. Well, sorting. Sorting is that invisible bridge that takes us from the mess on the left to the order on the right. So, the big question is, how do we actually do that? How does a computer take just any random pile of stuff and whip it into perfect order, like every single time without fail? Well, that is the secret we're going to unlock in this explainer. And the best part is, to really get the logic here, we don't need to look at any complex code or anything. Nope. All we need is a simple analogy that honestly, most of us have been using our entire lives, just sorting a hand of playing cards. Okay, so before we dive in, let's just get on the same page about what we mean. When we say sort, we're talking about one thing, rearranging a bunch of items into ascending or, increasing order. It sounds super simple, but trust me, the outcome is incredibly powerful. All right, let's make this real. Imagine you're in a card game and you get dealt this hand. You've got a queen, a 10, a 2, and a 6. It's just a mess, right? What's the very first thing you do, almost without thinking? You start putting them in order so you can actually see what you're working with. So what's the first logical step your brain takes? You scan the cards, right? You're looking for the smallest one, the lowest value, and boom, there it is, the 2 of spades. Easy peasy. And once you found it, what do? You grab that 2 and slide it all the way to the front, to the beginning of your hand. Just like that. One card is now exactly where it's supposed to be. Okay, so now you basically just ignore that 2. It's done. You look at the rest of the cards and do the exact same thing. Find the smallest one in the remaining pile, which is the 6, and you put it in the next open spot. It's just lather, rinse, repeat. And you keep going. Next is the 10, then the queen, and bam, your hand is perfectly sorted. And here's the cool part. Whether you knew it or not, you just performed one of the most fundamental algorithms in all of computer science. But, and this is a big but, this simple, powerful logic has a surprising weakness. Let's find out where it completely hits a wall. So this whole find the smallest, move it, and repeat thing, it seems totally foolproof, doesn't it? But here's the catch. This whole system, this elegant logic, it only works if the things you're trying to sort play by a very specific, unbreakable set of rules. And a perfect example of something that breaks these rules, good old rock, paper, scissors. Think about it. Does rock come before paper? Well, paper beats rock, so maybe. But wait, scissors beats paper, and rock beats scissors. See, it's a circle, a loop. There's no clear smallest or largest. If you asked a computer to sort this, it would just get stuck in a loop forever, completely confused. So there's a technical term for this sortability property. It's called a total order, and it's non-negotiable. For any sorting algorithm to have a chance of working, the collection of items, I don't care if it's numbers, words, dates, whatever, it absolutely must have a total order. So what on earth does that mean? Well, it really just boils down to 3 simple rules. Rule number 1, you have to be able to pick up any 2 items and know which one comes first. There can't be any ambiguity. Rule number 2, the logic has to be consistent. If A comes before B and B comes before C, then A has to come before C. That's the rule rock, paper, scissors totally breaks. And finally, rule number 3, it's a one-way street. You can't have a situation where A comes before B and B comes before A at the same time. That's just chaos. All right, so we need a total order. Got it. But this brings up an even more fascinating question, a real puzzle. If the rules for comparing things are so different, comparing numbers is nothing like comparing words. How can one single program possibly handle all of them? No, seriously, think about this for a second. The logic for sorting numbers by their value is completely different from sorting words alphabetically. And that's totally different from sorting files by, say, the date they were created. And, just for fun, how would you even start to write a program to sort Hogwarts students into their houses?
right? How can the very same fundamental logic, the same algorithm, apply to something as simple as alphabetizing your contacts and also, theoretically, figuring out if someone belongs in Gryffindor or Slytherin? The answer, it turns out, is just incredibly elegant.
Here's the secret, the absolute key to the whole thing. The sorting algorithm itself is actually kinda dumb. Seriously, it's a brilliant specialist, an absolute expert at one thing and one thing only: swapping items. It knows the mechanics of how to rearrange things perfectly, but it has zero idea why it's doing it. It doesn't know what bigger or smaller or comes first even means.
So here's how it works. Think of the algorithm like a referee in a game. It just grabs 2 items from the list, let's say 2 names from your contacts. Now, it doesn't try to compare them itself. No way. Instead, it holds them up and basically asks them, hey, you two, which one of you is supposed to come first? And the items themselves, the names, the numbers, the files, they have their own built-in rule. They know how to compare themselves. They just give the referee a simple answer, and the algorithm just trusts that answer and swaps them if it has to. That's it. And that separation of duties, it's pure genius. The algorithm handles the how, the physical act of swapping things around, and the items themselves handle the why, the actual logic of comparison. This simple idea is what makes sorting one of the most powerful, most flexible tools in the entire world of computer science. So what's the big takeaway from all this? Well, for one, sorting is way more than just alphabetizing a list. It is the fundamental hidden engine that turns useless raw data into structured, meaningful information that we can actually use. And the whole reason it works, the reason it's so universal, is because of that brilliant separation. The algorithm that does the moving is totally separate from the rules that do the comparing. So now that you see the pattern, now that you know the secret, I want you to look around your own digital life. I'm talking about your email inbox, your music playlists, your social media feed, your search results. Where else can you spot one of these hidden sorting algorithms? Just quietly working in the background, making your life a little easier by turning chaos into clarity.